Good afternoon, dear participant. Today we will have second session of course on geospatial technology for climate smart agriculture. Today we will discuss how geospatial applications are used in agriculture monitoring and food security. As we know, the way crop is grown, produced and marketed as well as eaten, consumed by the people is not simply food, it is a culture. So agriculture provides rich culture diversity and support livelihood of large masses not only in India but across the globe. So it is quite obvious to have this knowledge about how geospatial technology can help in achieving food security. Indian agriculture, well known, India is a land of agriculture and contributes cultural diversity and livelihood of the people. About more than 70% of people live in rural India, and agriculture is only the source of their income. So development of this rural India, we need to have a better agriculture, better monitoring of agriculture. And as apart from that, agriculture sector also changing social economic dimension due to liberalization, and recently government of India has also pushes digital transformation, which makes agriculture more attractive enterprise. Agriculture is central to the sustainable development goal because many goals like poverty, energy security, environmental security, water security, all are linked to the agriculture. Agriculture itself contribute to Indian economy around 20% of gross domestic output that comes from agriculture, and it generate 50% of employment. Indian agriculture, by statistic, if we go as on today, food grain production has touched almost 310 million tons. Of that, Kharif is 149 and Rabi is 159. Horticulture also around 331 million tons. But more specifically, agriculture contribute significantly both in gross domestic output, but its contribution in employment generation is quite noticeable. But problem with Indian agriculture with respect to monitoring, there is a small field size compared to US and other western countries, Europe, where we will find 100-hectare fields, but our field is largely 0.5 hectare. Also, Indian agriculture is affected by diversified climatology, physiography, cropping system, soil type, and so on. There is a climate regime ranging from arid to humid, soil from land to loamy sand, gravelly soil, red soil, lateritic soil, and so on. Physiography also we will find mountain, river terraces, flood plain, alluvial plain, then also peninsula. So there is a large scale diversity with respect to the all these factor determining the different kind of crop practice across the length and breadth of our country. So you can see there also there is large scale diversity with respect to the cropping system practice across India. There is sugarcane wheat system, there is groundnut based system, cotton based system, rice wheat system dominantly in Indo-Gangetic plain. So that all depend upon the climatic requirement, soil requirement, and physiography for different kind of crop practice across the region. More than 130 crops are there, which are grown throughout a year in India. So this kind of large scale diversity, or you can say heterogeneity in the different factor, to certain extent limit application potential of geospatial technology. However, tremendous uh, effort being made to demonstrate geospatial technology and its application for agriculture sector. More than 68% of application as on today realize with the use of remote sensing data is mainly for agriculture. So geospatial technology that comprises unique technologies like satellite, geographic information system, navigation satellite system, global navigation satellite system. Apart from that, certain data analytics, some ground sensing, drone, radar photogrammetry, and so on, altimeter. All these are very much useful with respect to the agriculture. Earth observation, mainly satellite, has got different kind of attribute like spatial resolution, temporal resolution, and spectral resolution. Spatial mainly ability to resolve a minimum area on the ground. Temporal means how many dates, how many frequently a particular area is being imaged. Spectral resolution means number of spectral channel or waveband within which information about the agriculture crops being acquired. GIS, that is a geographical relation database system, which helps to store, analyze, manipulate, and visualize partial and non-partial data. Partial data may be we can say different kind of imagery, with a vegetation index, land use, land cover, soil, different meteorological, solar radiation, and so on. And maybe past this non-partial data like crop cutting experiment, observatory ground agrometeorological observatory network, soil moisture sensing network, different kind of ground observation, and so on. So all this data you can integrate within GIS. GNSS that provide locational services mainly with respect to the food security. As I said in the last lecture, there is a one mobile application developed using Navic that helps fishermen to catch fishes, to identify the best location where fishermen can get better fish catch in the ocean, and also he can track route and come back to the same his own home safely. So these all GNS, it is very much utilized for precision agriculture also, to tailor crop and soil related input according to variability in the soil. So all this technology helps farmer as well as other stakeholder like policymaker, agricultural politician, agronomist, to make certain informed decision. So this particular satellite observation, which provide information on soil moisture, rainfall, crop vigor, crop growth stage, pest and disease damage, pest and disease attack, and so on. So all this information farmer require beginning of the crop sown, that at the time of land preparation or time of sowing, during mid growth stage, as a crop vigor, phenology for fertilizer application, for irrigation scheduling, you require phenological stage, you require this crop vigor and so on. During maturity also, you require harvesting information. What is the how harvesting is progress, or how sowing is progress. All this kind of information you can easily capture with the time series of satellite data. Agriculture, as I said in the last lecture, it is a backbone of Indian economy, and many of the applications being realized with the satellite remote sensing, beginning from the crop acreage and crop discrimination, drought monitoring, horticultural crop assessment, cropping system analysis, command irrigation command area management, soil mapping, pest disease monitoring, agricultural loan mapping, inland fisheries. Apart from this, there are also some mapping of watershed management, for hotspot area of solar radiation utilization, energy efficiency, more crop per drop, and so on. Many new crop insurance, precision agriculture. These are the new area where, with the availability of drone, partial analytics, and satellite imagery at the required interval, maybe weekly, with the high partial resolution, all make it possible to monitor crop begin from field scale to almost regional scale. So today in India, satellite, we are maybe the fourth country which are using satellite based observation for regular updation of the crop status, and this information is quite useful for achieving sustainability of agriculture. So today we are using ISRO, means ISRO is using both optical and radar imagery for widely in monitoring agriculture. Earth observation, if supplemented with other information, can also provide information related to the any anomalies due to pest, weather, or weather anomalies. There are different characteristics of satellite data with respect to the agriculture. Mainly, satellite may be having multispectral observation. As I said, number of spectral channel or spectral band. More number of spectral bands, it will have allows better discrimination of crop growth and identification of crops and crop assessment, like hyperspectral. Synoptic coverage at multiple spatial resolution means large area. Satellite can enables you to map large area with multiple spatial resolution, so you can monitor a particular district level crop acreage estimation to almost country or nation. Multi-temporal means how frequently a satellite image available for a particular farm. So multiple observation in a crop season. You can have today with the Sentinel or other advanced Swift kind of data within a week. You can have one satellite imagery within a week. So you can at least monitor crop growth condition, crop growth stage, which are quite useful for scheduling different kind of farm application. Multiple utility, same data, same like, okay, whether it is a resource set from India's remote sensing satellite or any other satellite, same data can be useful for the crop mapping, crop monitoring, yield estimation, as well as land use land curve mapping and so on. So there are plenty of advantages that remote sensing data has got with respect to its application in agriculture. From as of now, remote sensing, Indian remote sensing satellite and sensor available for agriculture application are many. So some of the few example which I highlighted here, there is a one resources satellite which has got 3 sensor on board: LIS 4, LIS 3, and advanced sweeps. LIS 4, which is mainly useful for the field boundary detection or cadastral level field scale mapping of the different kind of crop. LIS 3, which is available at imagery available at 23 0.55 meter resolution and every 24 days. That means it can be useful to monitor, have crop growth monitoring, as a crop growth stage identification, or you can say better crop discrimination of multi-crop region. Advanced chips. This is the one sensor which is quite moderate resolution, like 56 meter, but its image is available every 5 days. So you can use dynamic monitoring of the crop growth condition as well as phenological stages, and also it can enables you to get agricultural drought monitoring for certain drought related management. SAR data. There are also some SAR data, means synthetic aperture radar, which is one of the recently launched satellite is a RESET, Earth Observation Satellite 404 mission. So that is mainly ideally suited for the agriculture application, particularly during the cloudy season, mainly Kharif season. When during cloudy season, all above data like resource satellite, which is optical, so it cannot give information about the crop due to cloud contamination. But SAR data, which has got capability to see through cloud, and it is independent of weather condition, so you can enable to capture, you are able to capture information about the kharif crops. That is why SAR data is widely being used for monitoring paddy crop growing condition and paddy crop yield estimation. It is operationally being utilized in India for paddy crop monitoring. Another satellite is also there, that is OceanSat, which is having a ocean color monitor on board. OCM has got certain channel like visible and near infrared, which can makes you to generate vegetation condition index, which is vital for the monitoring crop condition and the drought, agricultural drought. So there are many other satellite from the other launched by the other space agency like ESA, European Space Agency, NASA, and so on. So like, okay, there is a satellite like TRMM, Tropical Rain Measuring Mission, and MSRE, which can provide rainfall and soil moisture. So this rainfall and soil moisture, which is vital during the land preparation to make some informed decision about the land preparation, sowing suitability analysis, whether particular area is suitable for the sowing of particular crop just after okay rainy event happen. So if this information on the rainfall and soil moisture provided timely to the policy maker or you can decision maker, then this information can be used by the district agriculture officer, so he can properly guide the farmer to okay whether to sow crop or not. IIRS and Modis, they are providing large number of biophysical variable like okay vegetation index, action of photosynthetic active radiation, albedo, leaf area index, and so on. So it is very much useful to get evapotranspiration estimation, radiation, and so on. Similarly, there is another satellite GRACE, which is gravity based. It analyzes gravity anomaly. So it is nowadays okay linked to the total soil water storage. So one can analyze soil groundwater storage possibility as well as soil moisture. So all these satellite that can help to retrieve biophysical variable, hydrological variable, as well as atmospheric variable, which are vital with respect to the agriculture. As I said earlier, agriculture take place under open sky. Farmer doesn't have any control. So it is influenced by the atmospheric parameter, it is influenced by the hydrological parameter as well as some biophysical variable which are controlling the growth and development of the crop. Crop inventory. Suppose we want to make use of the satellite data for crop acreage estimation, because different crops has got different kind of canopy cover, leaf cover, composition, phenology, and crop calendar. So different crops grown at different time. All these characteristics helps user or helps interpreter to make distinction between the two crops with the satellite imagery, because these different characteristics resulting into a different amount of energy being reflected and detected by the satellite sensor in the space orbit. And this form different reflective energy from different crops makes unique signature, which can be identified with the some kind of computer based algorithm. So one crop identification means more concerned with the classifying all crop types from each other. So it is very much challenging task. If you want to discriminate all crop types in a region, it is challenging task. So it is called crop discrimination or crop type identification. Because there are region like Gujarat, Maharashtra, or some other Andhra, some other region where multiple crop are practiced in the within a 1 hectare field. So it is very difficult to classify or discriminate all crops. But if user interest is to have acreage estimation of particular crop, then he should concern only with the target crop. That means all methodology, acquisition of the satellite data, as well as satellite as well as ground truth information, he should emphasize mainly on the particular crop. So here you can see how it is useful, their signature. This is a one advanced image with the green, red and near infrared and short wave infrared band. Image was acquired during the first week of March of Haryana region. Now here you see in Haryana, first week of March, wheat crop was in the peak growth stage. Then mustard, it was just about to mature or about to harvest in dry stage. And sugarcane is almost harvested. Only some stem is left for growing next year, like ratoon. So here, because of peak growth stage, it is in near infrared region, there is a more multiple scattering at the cell wall interface. So more reflectors is there. In case of mustard, it was there was a in maturity stage during the first week of March. So there was little less scattering, but scattering was there from the beneath leaves. For sugarcane, it was almost harvested. There was only stem left, so there was no scattering in the near infrared range. Similar inverse response with the visible. Absorption was more, chlorophyll related absorption of the red wavelength more because of more chlorophyll concentration at maximum vegetative growth stage. But in sugarcane, there was no leaves, so there was least chlorophyll absorption. So with these only two band, even we could able to discriminate all these three crop with the single date. So you can see this you can see we could be able to do classification of the sugarcane, wheat and mustard crop with these three. Similarly, there is also one another crop area where Kolhapur Tehsil in Maharashtra, we could able to discriminate sugarcane, paddy, sunflower and groundnut crops with the least 3 image, which is a 23.5 meter spatial resolution, but ground truth supported with the whenever there is a satellite image pass is there, one has to acquire ground truth information by visiting that particular field campaign in the field campaign mode. But after they are collecting ground truth, which are the crop cultivated, what is the locational coordinate of that particular crop, and then after it is used for the classification. So here you can see we could able to classify. Then also there is up to even some paddy basmati variety and old variety we could able to classify with in the Saharanpur one Behat block. So here it doesn't mean that these three can classify all variety. No, it should not. One should not take like that. It can, because this is for some unique area where, because of difference in the phenological calendar, time of sowing and harvesting of the crop due to variety. As a result, we could able to identify the distinct signature of these two variety So we could able to discriminate. But it is not universal that these three can be, or multispectral images with the resolution of 23.5 meter could able to classify different variety. For that varietal discrimination, one should go for the hyperspectral imaging. So that was all about the some research purpose, tehsil or district level acreage estimation. So but if we want to have acreage estimation of whole state or nation, we cannot take acquire imagery for whole India or whole state. We need to apply certain kind of stratification procedure. Stratification may be on the basis of agroecological zone, previous year historical crop proportion, or previous year satellite imagery. After stratifying this whole region, you can do segmentation procedure. Means you can overlay 5 by 5 kilometer or 7.5 by 7.5 kilometer segment grid over the image, over the area. So here you can see 5 by 5 kilometer grid is overlaid over Haryana. Then only 10% of that square boxes segment you can select for acquisition of the satellite image. After acquiring satellite image, ground truth is located. Ground truth has to be identified within the satellite image by taking ground truth. Then finally classification has to be performed. That there's a classification of that selected sample segment for particular stratum is only classified. Then after, based on the stratum proportion of the crop percentage multiplied with the acreage of the sample segment selected within particular district, gives you a aggregated crop acreage of the particular district. Similarly, then question will come to many people minds. Can single date provides acreage estimation of all crop for whole state or in India? Then answer is no. Because in different across crop is same wheat, but in different state time of sowing of crop varying depending upon the farmer economic condition as well as other factor, climatic and soil factor. So because of time sowing, variation in the sowing time or sowing window, you cannot have a particular unique date of acquisition of satellite image that can enables you to classify wheat crop across the whole India. So we need to have, to overcome this problem, we need to have a multi-date data. Means acquire imagery for 4, 5 or 6 times in a growing season of wheat crop. Here you see this is a NDVI profile, normalized difference vegetation index profile of the wheat crop, that brown color. Now here this is wheat crop is sown by first week of November and it is getting harvested by mid of the April. But mustard, another is a mustard sown by end of October and get harvested by first week of March. Now here one curiosity or quest will be there, why there is a dip or why there are two peaks in case of mustard. So normalized difference vegetation index, it is nothing but the it is the difference between NIR minus R divided by NIR plus R. It is an indicator of vegetation index. So R means R absorption, when vegetation growth is more, chlorophyll concentration is more, R get absorbed, R wavelength of red wavelength get absorbed. But say at the same time near infrared wavelength get scattered, means more will be the reflectance. So here when during sowing, first tillering stage will take leafing and tillering stage will be there will be a one peak because of vegetation growth. Then when this mustard crop turns into a yellow during flowering stage, so flower doesn't have chlorophyll. As a result, leaf area index or green area index come down. So its NDVI normalized difference vegetation index come down. Again that flowers turns to the pod, and pods are green which contain more chlorophyll. So it again contribute towards more reflectance in the NIR and more absorption of the red wavelength. As a result, NDVI goes up. Again there will be a senescence of the crop due to maturity, leaves, drying of leaves, yellowing of leaves, and finally maturity. So that is why there are two peaks. So here I wanted to suggest that when your target is to estimate mustard acreage, one should acquire satellite imagery during the flowering stage. That means mid of the January. If your interest is to estimate acreage of the wheat crop, then one supposed to acquire satellite imagery, particularly advanced sweeps or lease 3 imagery during the maximum vegetative growth stage, which is attained in the mid of February to up to first week of March in case of wheat. Now that was all about the state level or national level approach, but at the same time now new technology is being developed to make sugarcane or means high resolution crop inventory at field scale. So we could able to here map sugarcane, both ratoon and planted sugarcane. Planted sugarcane means sugarcane set is planted and it is harvested at the end. And ratoon is that sugarcane set is planted and it will mature. Once maturity is there, it is cut from the keeping certain portion left behind to regrow for the next year. Once it is regrow for the next year, it will be called ratoon crop. So that ratoon and planted could able to map with the multi-date classifier as well as list 4 image segmentation technique for the Kisan Sahkari mill. So we could achieve very good accuracy. This is only very much required for to decide crushing capacity of sugarcane by the mill owner. So here you can see all this from if you require India level crop acreage estimation, you can use coarse resolution like WIPS 180 meter resolution. If you are interested state level, you can use advanced WIPS kind of resolution 56 meter. If you are interested district, you can use list 3. If your interest is mandal level or village level, you can even further go up to high resolution satellite data like list 4. But with the improvement in the spatial resolution, you can better classify more number of crops. But here only you can do rice and wheat, because these are the two crops, wheat, rice and wheat. These are the two staple crops and occupy majority of land mass or net sown area in India. But that is all about the Rabi crops. But our rice, which is the first and foremost staple crop, food grain crop in India, which is practiced mainly during the rainy season, cloudy season, means Kharif season. But our interest has to be there to map accurately rice area and rice production. So for that we need to depends on the active microwave remote sensing data like reset, radar set, or IIRS or Pulsar. So here recently we are having a one EOS 4 mission which support rice crop monitoring. So backscatter signal here, it is like that during planting there is a peculiar backscatter. Then once with the growth, vegetation growth, there will be a volume scattering. So because of this distinction between the transplanting time and the vegetation growth stage time, there is a distinct signature of backscatter signature which helps rice crop to be easily discriminated from the other crops. But still for the other crop like sorghum, bajra, jowar, other kind of millets and sugarcane, still this microwave remote sensing data is still in the research stage. But rice crop as of now, it is operationally being monitored with the active microwave remote sensing based SAR data. Here you can see even basmati and non-basmati rice. You can monitor with the multi-date radar satellite data based on the difference in the crop calendar, harvesting and maturity time. So here you see both at the time of maturity time, both has got different kind of backscatter signature across different polarimetric parameter. So that helps to discriminate basmati and non-basmati rice. But limitations are also there. Small size, field size in India, large diversity of crop sown, large field to field diversity in sowing culture. That means time of sowing, in some like Haryana, Punjab, wheat crop is sown in the November, but in Himachal and Uttarakhand, Himachal, it is sown in the January also. So there is a lot of variation in the time of sowing, which result into the variation in the attainment of different stages. So you will find sometimes wheat crop with the in the different growth stage, and sometimes there is the same crop with the different crop with the equivalent growth stage. So spectral confusion may be there with the different kind of satellite data. In India, we are dominated by the poor and marginal and small farmer. So there is a practice of mixed cropping, intercropping to get more remunerative net return. So this kind of intercropping means repetitive arrangement of row crops in two or more crops in the row arrangement. Mixed crop, mixing of seeds of two or more crops and throwing on the field. So this kind of practice not possible to differentiate. High cloud coverage. We are in the tropical monsoon Asia, so which is dominated by the cloud cover condition. So at least from July to August, September, 3 months is dominantly completely covered by the cloud. So it is impossible to get the quality data from optical satellite data. We need to depend only on the microwave remote sensing satellites, so which is also in limited frequency across the world. There are different frequency factor like radiometric resolution, time of acquisition, atmospheric parameter and environmental factor all affect the crop acreage estimation. Now after crop acreage estimation is one of the important area where we need to monitor crop area, but along crop area doesn't serve purpose to monitor the crop performance. We need to have a monitoring of the crop production, and crop production that implies to the acreage multiplies with the crop productivity. So crop yield is not the simple, it is a challenging task to estimate or to map crop yield, because crop yield is a manifestation of weather, soil, crop and agronomic management. All this because all these factors affect the crop yield or productivity. Crop productivity, but important with respect to achieving sustainable development and food security, because food security term itself implies that every nation should provide to everyone at all times physical, economical and cheap food accessible to the everyone for their dietary needs. This can be achieved either growing of crops on the farmland of the particular country, or raising livestock, or importing food from other countries. But that is food security. So it is very much important for the food security related policy decision whether we need to import whenever there is some kind of you can say calamities like drought, or you can flood, or some kind of crisis, food crisis are there, then countries need to take certain policy decision to import food grain. Likewise, for some 7-8 years back, there was a huge price rise of the pulses. So government has to procure pulses from other countries to meet the nutritional security of the countrymen. So that kind of import and export decision, that all depends on the availability of food grain production, either they are cereals, pulses or oil seeds. Crop yield estimation using geospatial technology that covers remote sensing, GIS and models form on certain basis. One of the important thing is that satellite provides observation over large area and during throughout whole growing season. So that is why it provides some kind of crop monitoring techniques. Apart from that, there is a strong relation exists between the satellite derived measures, whether it is a land surface temperature, vegetation index, chlorophyll concentration, whatever you retrieve from the satellite has got close relation with the crop parameter like biomass, leaf area index, chlorophyll density, photosynthetic activity, net primary productivity, all are closely related with the satellite derived measures of the vegetation. So this particular strong association is explored to develop certain kind of crop yield estimation method. Apart from this satellite remote sensing, there is a GIS, geographical information database, which collect data from the diverse sources, whether it is a historical climate model database, or it is a soil database, or it is a management database, or in situ measurement. All that can be integrated within the GIS to create partial database or simulation zone to run the climate crop model for better predicting crop yield. So there are different approaches. One is a simple statistical approach where vegetation index acquired during the maximum growth stage can be related directly to the crop yield. So nowadays, okay, historical crop yield available from the Ministry of Agriculture and Farmer Welfare, the agriculture statistic at a glance. So you can get the district level crop yield of any crop, then acquire satellite imagery during the maximum vegetative growth stage of that crop or most ideal stage of the crop, and then develop relation to estimate crop yield for the next year. Then there is some multi-date spectral growth profile approach or phenology based approach, which takes into account entire growing season satellite imagery acquired at different interval covering entire growing season to understand start of growing season, peak photosynthesis date, peak value of greenness, and end of growing season, photosynthetic duration, and so on. Many phenological matrices, those can be related directly with the crop yield, district level or block level, and develop an approach that can be estimated for useful for the modeling. So all this, okay, I will show you one by one. So this is a one approach, phenology based approach, which we have tested for the cotton crop in Marathwada region. Now here you see with the Modi's data, every 16 days interval, we could able to, for 11 years, we have generated time series of 11 years. Then with the time set, we could able to identify the emergence date, means start of season, and end of season, which is end of season related to the maturity, and this is a light, okay, emergence or greenness. So length of duration also we could able to identify, amplitude, peak value of greenness, NDVI. So all these phenological matrices like start of season, end of season, peak time, peak value, amplitude of the NDVI, the end of season, and length of growing season, all related with the cotton lint yield for 11 years, and we could able to develop a model which covers peak NDVI and amplitude of the NDVI for forecasting and length of growing season for yield estimating yield in the Marathwada region. So this all exercise is done for the 10 to 11 years, and then this particular model equation, multivariate equation, is developed to forecast or estimate cotton yield in case of Marathwada 5 district. Another approach is deterministic biomass production approach, or you can say semi-physical crop growth model, which is based on the classical growth analysis approach suggested by the Monteith, which is also called efficiency based model or light use efficiency approach. Here, amount of energy, all the dry matter or biomass which are produced by the plant canopies, it is a function of the amount of absorbed photosynthetically active radiation, that means sunlight. Sunlight is largely used for the driving photosynthesis process, and through photosynthesis plant makes food, means convert water and carbon dioxide into a carbohydrate, which is called carbohydrate, that is nothing but dry matter, and there is a loss of this CO2 through respiration, which is called release of CO2 through respiration. So finally net primary productivity we can evaluate, means amount of carbon fixed in the plant canopies or carbon dioxide fixed in the plant canopies via photosynthesis and allocated to biomass. This all can be acquired from the either remote sensing data. This is also possible from the Earth observation satellite data, fraction of absorbed photosynthetic active radiation, photosynthetic active radiation, which is a part of solar radiation, which is observed by the satellite, instead solar radiation means geostationary satellite, or simply cloud properties from the some Earth observation satellite also. We could able to make this use of this for the Haryana region, where wheat crop acreage, as I have shown earlier, wheat area where you classify with the advanced sweeps, you get wheat area. So particular 8 days NDVI from Modi's, that same 8-day period photosynthetic active radiation, then FFR means fraction of absorbed photosynthetic radiation, which is directly related to the vegetation index. So you can develop some simple relationship between this crop parameter with the vegetation index, what you can estimate derive from the satellite imagery. After getting this FFR, you multiply with PAR, you will get absorbed photosynthetically active radiation. Absorbed photosynthetic active radiation you multiply with light use efficiency, you will get finally net primary productivity for every 8 days. Then you sum for the whole growing season, you will get finally crop yield like this. Okay, you Haryana region for 2 FFR based approach. Here you can see for Haryana, majority of district within 10% of the official estimate, this efficiency based or semi empirical physical model could able to estimate. Western UP also within 10% of the official estimate you can get with this kind of light use efficiency based model. Same approach we could explore, it can be explored for the field scale estimation of yield with the large amount of satellite data, because with nowadays technology is growing, more and more satellite data with the capability to estimate growing season, start of sowing, then data is available for the moisture related constant, data is available from the climate model, data is available from the geostationary satellite which provide solar radiation on a partial basis. So here we could be able to use satellite Sentinel-1 with the 10-meter spatial resolution on weekly basis to estimate crop phenology, start of season, end of season, as well as peak value and so on. Then INSET 3D is solar radiation data, which is used for the estimating photosynthetic active radiation. Then IRA interim, that climate model data, IRA interim reanalysis data, that is useful for the temperature stress or temperature limiting factor. Sentinel-2 data set, which is useful for the estimating FFR, leafy index, and through NDVI, and also useful for the water surface wetness index. All this data is used to parameterize this efficiency based model and use for every field. Every field it is estimated, used to derive the yield of the sugarcane crop. So here you can see for one Sahkari chini mill, for every different villages, we could able to estimate for every field within the village what is the yield of sugarcane crop. now it has become the more operational approach, and has been implemented by the MNCFC. So all this research, either it is done by IIRS or it is done by the Space Application Center with the use of semi-empirical, semi-physical crop model applicable over different area, Punjab, Haryana, Bihar, Haryana, or whatever research, all research technology is being transferred to the Mahalanobis National Crop Forecast Center for operationally estimating yield of the different crops in every year. So this is the technology. Now it is about to reach maturity to make use for the operational estimation of certain crops, not all crops, certain crops it is possible. Latest, okay, now integrated, okay, some advanced technology also is being explored or tested to have advanced forecast, because we need to have a early forecast if you want to anyhow, okay, we want to help farmer or we want to help policy maker to have certain, okay, contingency planning, or have to make certain informed decision related to the management, crop management. Then we need to have a at least 1 month ahead of the harvest crop yield forecast has to be given. So that can be possible with the integration of geospatial technology like remote sensing and GIS, crop model and climate model. Climate model can simulate the weather during the growing season in advance, seasonal weather forecast. Crop model are nothing but the software that helps to simulate behavior of plant as a function of environment management condition. So it can help you to simulate the leaf area index, daily dry matter production, water balance, and finally yield at the harvest. So if you integrate all those things on a grid basis of 1 kilometer or to 5 kilometer, you can estimate yield of the wheat crop at the with the different lead time, up to 45 days in advance, 30 days in advance, 14 days in advance, and so on. Same, okay, you can use also for the drought forecasting. So Haryana and Punjab, here also we could able to see rice. How best we could able to predict yield of the rice crop in 2009 and 2014 with the integration of the this remote sensing, climate model, particular WRF, and the crop simulation model DSET rice, cirrus rice. So integrating this, we could able to capture best estimation of the yield of Punjab and Haryana particular rice. At the same time, we could able to capture the water stress, detect the water stress partially with the integrated climate model, crop model, and the remote sensing. So here you can see we could able to simulate crop yield anomaly as a part of the drought indicator, and also you can see here water stress which is simulated with the this integrated methodology against the actual observed yield anomaly. We are finding negative relationship, so means we could able to capture water stress with this integrated indicator of the climate crop modeling with the in the geospatial manner. So this is the one of the case study which is published in the scientific report Nature journal. So you can have this look. Institutionalization of agriculture monitoring. So there is a ISRO has institutionalized this Mahalanobis National Forecast Center, which aims to forecast crop acreage and also production of the different more than 8 to 12 crops as of now. More number of crops for this prototype development of the crop yield crop forecasting is in progress to cover all 24 MSP minimum to cover all 24 crops which are under minimum support price. So there are different kind of econometric model, agrometeorology based model, then satellite based model. All are developed by integrating information from satellite, meteorology, and the land based observation to have better forecast of the crop yield. Apart from this, okay, crop yield estimation, crop condition monitoring is adequately important. So here you can see stress vegetation has got different kind of signature in the electromagnetic spectrum, whereas Healthy crop has got different kind of signature. Stress crop which has got different higher reflectance in short wave infrared band, less scattering in case of near infrared, and more reflectance in case of visible range. Reverse in case of healthy vegetation. So these satellite data which are very much useful for detecting the crop departure, crop anomaly or crop condition, which is an indicator of the crop maybe due to crop disease, insect pest damage, crop stress, disease, disaster damage like flood, drought, and hailstorm. All this abiotic stress or biotic stress that can be possible to monitor with the different kind of satellite imagery acquire beginning from the visible, near infrared, short wave infrared, thermal infrared, as well as active microwave. So one of the area is that is national agriculture drought monitoring, where all kind of data, optical NDVI, then also soil moisture from MSRE, and also LSWI, NDVI, all data are useful for agriculture drought monitoring, because agriculture drought means inadequacy of soil moisture in the root zone to meet the water requirement of crop plant. So whenever we need to monitor fluctuation in the soil moisture and drought impacted crop condition along with the rainfall data. So we can get wetness from the this sphere band kind of normalized difference vegetation index, MSRE or soil water balance technique. All are useful for the soil moisture generation. Then also we can get drought impacted vegetation condition with the OCM or advanced sweeps kind of satellite data. All can help to demarcate different kind of moderate, slight, and the severe drought condition. So these are the NOAA, Terra Modi's, IRS sweeps, and IRS advanced sweeps. All data are useful for the monitoring crop condition or agriculture drought, because these are the data which provide available on a daily basis or weekly basis. How it works? Weather data, there are geostationary satellite data, rain gauge, automatic weather station, soil moisture, you can get water balance, microwave, thermal, crop condition from the optical satellite data, agrometeorological yield model, and so on. Crop zone area also you can get from the satellite observation like SASI, slope angle index. All this information you can integrate to get drought severity classification like this: mild drought, normal, mild drought, moderate drought, or severe drought condition. So this is a one approach of the crop condition monitoring which is affected because of the drought. And so another way also, Modi's data, here you can see the one example of 2002 drought. Every weekly we could able to monitor this eastern Rajasthan. You see all stress condition, entire growing season almost under stress condition. Drought stress was there, a whole eastern Rajasthan, yellow to red. But next year 2003 it was almost normal condition, and it can be visualized compared with the crop moisture index estimated from the ground observation also. So ground observation you can see here all is negative. Negative crop moisture index means crop was under drought, but here it is all positive. Crop moisture index is all positive. That means it is above normal moisture, soil moisture condition was there. So it is corroborated for the entire growing season that drought condition can be easily affected crop condition can be easily captured and monitored with the frequently available satellite imagery, either from Modi's, advanced sweeps, or other satellite data. Then one can also generate certain kind of drought food security indicator like water requirement satisfaction index. There some water crop specific water balance model, you can integrate rainfall from satellite, potential evapotranspiration from satellite like INSAT 3D, available water holding capacity, that is a soil based capacity, crop type map, phenological parameters, start of season, length of growing period. All these remote sensing derived parameter you can integrate to derive water requirement satisfaction index for different crops, and this can be used as an indicator of the good crop, fair crop, or bad crop, or failure of the crop. So you can see this is one of the good indicator which has been practiced by the Food and Agriculture Organization to monitor crop condition and food security within the Africa. It is largely being used by the FAO, this particular approach. Horticulture development also nowadays, okay, one can do, okay, crop suitability for the different horticulture crop area estimation, monitoring of, okay, urban horticulture, crop spectral library, and so on. All these different area, or food processing park, for identification of cold storage facilities for the horticulture crop output, all can be possible with the geospatial technology to get the real assessment of the food secure areas. You see one example here, mango orchard. They are, okay, with the advanced technique of the machine learning algorithm and image segmentation can help to detect where mango orchards are there. Old orchard and the young orchard we could able to map with the support of the ground truth. So today there are the advancement in the image processing technology, like, okay, machine learning algorithms are there, image segmentation algorithms are there, apart from the improvement in the spatial resolution of satellite imagery, as well as how frequently satellite imagery available. So now one can make wonder to get even crop information, mango orchard, and all those you can map every field level. So all those, okay, we have already discussed in last lecture that all this information is useful for crop condition monitoring, apart from identifying the damage that is caused due to white fly or hailstorm or any other kind of, okay, stresses, abiotic or biotic stress, that can be used for finally compensation given to the farmer. Means identify how much crop insurance studies. So this is one application where hailstorm, particularly hailstorm damage, can be assessed. Hailstorm, they have crop stress is there, crop condition is get affected because of hailstorm. In this is one area that is near in Meerut. There is one village where there was a hailstorm. Just before hailstorm, one imagery was acquired, and after hailstorm, imagery was acquired. So wherever good crop was there, it is all affected, damaged, and it is captured easily with the post hailstorm satellite imagery acquired by the resource satellite or Indian remote sensing satellite. So you see the change in NDVI also. NDVI, okay, declined drastically with respect to the pre-hailstorm NDVI, and this is finally converted into the moderately affected area, severely affected, and highly affected different field parcel of the potato crop. So nowadays with the high resolution imagery and research focus on unmanned aerial vehicle. Now unmanned aerial vehicle drones based satellite imagery is easily obtained, and that can be used to monitor any kind of crop damage, whether it is due to pest disease or it is due to hailstorm or some other kind of natural calamities, to support crop insurance by insurance companies. Crop loss assessment can also be possible due to damage caused by the cyclonic flood. So here unseasonal rain and hailstorm impact. Apart from that, there is a cyclonic Patel cyclone which has caused large scale damage in the crop area. So Odisha coast, there how much agriculture is affected. Like you see super cyclone and Patel cyclone. There is a production anomaly you can see. Patel cyclone has drastically affected the crop area of different district in the Odisha coast compared to the super cyclone. So this kind of damage assessment and crop area decline, crop area affected, can be also mapped with the satellite imagery. This drone, it is making providing a new dimension to the way how we can approach agriculture, how we can monitor agriculture, and how we can manage our farm. So because it has ability to map land record, it has ability to monitor crop condition, soil properties, and nutritional deficiency, pest and disease, irrigation, and also management means spraying of insecticide, pesticide, fertilizer, all can be done with the drone. One is the monitoring, mapping, monitoring, and assessing the crop and soil variability within the farm, as well as you can do spraying of different crop input. So that is a wonder technology which now farmers are going to experience in the next coming decade, because government is pushing drone based agriculture to digital make complete transformation of agriculture to digital agriculture. So here you can see this is crop yield map, cotton crop yield map for one farm, one field it is generated, how it is varying. There are okay, good crop, bad crop, all you can see within the row, even row wise. Similarly, crop coefficient for water requirement also every field, you can see the variation. Hyperspectral, it is also under development, and it is going to bring okay sea changes in the way we are able to look at the different kind of stresses which are very much important for precision agriculture. So with the hyperspectral imagery, if we are having on the drone technology, then it can enables you to identify different kind of stress, water, pest, disease, nutrient. As of now, we are not able to identify different kind of stress. Only we could able to do what is the stress is there. Plant is under stress. But if you are to ascertain different kind of stress, causes of stress, then only you can apply what is the remedies. What is a measure of management action. So for that you need to identify the stress, yield and vitality indicator, soil under contamination, soil organic carbon status, means carbon footprint, and so on. All you can able to do with the hyperspectral remote sensing. There are also some innovative technologies being developed, that is sun induced fluorescence. All we have talked about the only NDVI and other kind of measures, but now sun induced fluorescence, some satellites are available which provides data like okay SIF, which is useful for photosynthetic activity, and also mapping different kind of crop. You see it can be achieved with the space borne, aerial borne, and ground based sun induced fluorescence. And today we are having so many satellites globally available which provide sun induced fluorescence. So it can be here okay we could able to use okay wheat crop yield estimation with the in the Australia, Muri, Darling, Beijing, and also Indo-Gangetic Plain of India. So you can see we could able to find good relationship between sun induced fluorescence with the wheat yield in India and Australia compared to NDVI in all optical measure of the derived from the satellite. There are many across the world. Early warning systems are developed for monitoring crop condition, early warning about the farm condition. So these are the farm early warning, famine early warning system, Mars monitoring agriculture remote sensing by European Community, energy balance monitoring, then also Patel, that is India. This is also SADC, that is Africa. So here you see this GeoGlam. GeoGlam, that is a global agriculture monitoring system where all globally 4 crop monitor wheat, soybean, maize, and wheat, soybean, maize, and sorghum. So here all of the earth observation data, in situ data, and weather forecast are analyzed to give crop status, crop condition, and the status early outlook of the area of the crop condition or crops. Here you see this all you can have a okay every monthly NDVI temperature, and this all precipitation, soil moisture, and all anomalies that is analyzed to provide the crop outlook like this. What is the crop stage, whether crop is under watch, crop is under good condition, Here you see in India, March there was a hot summer. Because of that, crop maturity was hastened. As a result, there was a worse like crop condition in March is poor in certain area, and it going to be harvested early. So this kind of information all globally it is analyzed for the four crops, that okay, this wheat, maize, rice and soybean. So this is complete crop monitor and crop marketing information also made available through geograph. So there are many early warning systems. This is a one fuse famine early warning system which also integrate remote sensing data, rainfall estimation, snow cover, forecast, means weather forecast product, climatic product, climate analysis to get the food security indicator like crop soil water index and so on. Then there is a Mars European Union which is using satellite data, in situ measurement, weather forecast to model crop yield with three indicator: remote sensing, trend indicator, crop simulation model and remote sensing. All four kind of indicator are used for the yield estimation of the different crops in European region. Similarly, in case of Africa, other mainly photosynthesis and evapotranspiration based approach is used to get the better picture about the biomass production and the crop yield forecast. So it is based on the Monteith approach and the evapotranspiration, relative evapotranspiration based approach. So relative yield estimation of different with the geostationary satellite data and others are given. So that is all about how best satellite data in India as well as across the world being used for monitoring crop condition, yield estimation, identifying crop acreage, agriculture drought, crop loss estimation, crop insurance related studies, as well as new advances. Either it is a drone technology, sun induced fluorescence, or hyperspectral images, how things will change in the future. That all we discuss. Let's have work towards achieving food security for to achieve sustainable development goal like to alleviate poverty, be sure to make more energy secure, food secure, and the environmentally secure